Okay, we're in section 1 of the notes, and we've covered this section already. This is the trigonometric function section. Once you're done covering the entire section 1 of the notes, you were to then go to WebAssign and complete the Math 120 topic 1 of the WebAssign. You should also consider contributing to the discussion group. Try to talk about resources or what's helping you learn the material. All right, so what do we do in week 1? I should say in section 1. We talked about, angles and rotations, yada, yada, yada. This stuff has all been covered. I want to point out in the notes, there's little tiny videos over here. If they're helpful, watch them. If they're not helpful, don't watch them, right? Your intent is to learn the material as being presented in class, all right? So we covered this angles and rotation business. We cover center position, initial side, terminal side, positive angles, negative angles, clockwise, counterclockwise, right? We discussed measuring systems. Measuring systems, you're familiar with rotations, revolutions, degrees certainly, and something new, which is the radian measure, right? Radian measure is going to be important because it's unitless. So we did talk about that. Hopefully that's been understood and you've studied that material, all right? We talked about standard pictures over here. We talked about the definition of what 1 radian looks like. And we can't put a formula for arc length. S equals r theta. Theta has to be in radian. We talked about converting back and forth between the systems, going from degree to radian, radian to degree, revolution degree, and, basically moving around through the different measuring systems. Again, you should be very familiar with degrees and revolutions. It's the radians that most people are not familiar with. Over time, though, you become more familiar with radian as well, all right? We talked about special triangles. The special triangles we talked about was a 45, 45, 90. We drew pictures of that. We hope that made sense to you as we gave you those pictures, not to be memorized, to be understood. We talked about the 30, 60, 90 triangle. Again, the key there is hopefully you start to see these triangles as being very simplistic triangles that you've seen since you've been in grade school. And you want to know the sides of those triangles, not by memorization, but by reasoning skills. We talked about a reference angle. A reference is going to be an acute angle. An acute angle is going to be between 0 and 90. That's formed with the x-axis, all right, from the terminal side. And again, we went through a bunch of pictures with respect to that. Then we got to this diagram over here. And this is where a lot of teachers say, oh, you need to memorize this. You got to memorize this because it's sort of like memorizing a poetry or something. No, you don't understand this. So over here, if you look at this thing over here, this is a unit circle centered at the origin. I got some points down over here, like 1, 0 should be obvious. And we went through every single point on this thing over here. Here's the key though. The reference angles, what we said they're going to be 30, 60, or 45. Really simple stuff. Now the ones that fall on the axes are really easy to do, all right? As we go through problems, we talked about that, all right? That was a unit circle picture. We talked about circular functions. The circle that we like is a circle that's centered at the origin, and we like the x squared plus y squared equals r squared. If you have a unit circle, the r would be 1, of course. Then we got these definitions, and the theta was in standard position for the angle, and we had the sine function being defined a certain way. And the y really is going to be the ordinate, and the r is the radius of this circle problem, these circular functions. We did the cosine, we did tangent, and we spent a lot of time talking about that, all right? And then, we talked about we could use different letters, but whether we use different letters or not, the letters still have the same meaning. And I want to put those meanings to the letters. R is radius of a circle centered at the origin. We have an ordinate, and that's going to be the vertical rise. And then we have an abscissa, which is going to be the horizontal, all right? So, we went through the definitions of those. Hopefully those, you start to make sense of those. Then we did a bunch of examples. Now, I really mean that. We did them in class, yada, 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 every single example. Next to the example, there's little tiny videos. In those videos, you can watch those. If you can't remember what was in class or you need refreshing, just watch the videos again, or you can watch the whole lecture again if you like. That was prior lectures, by the way. Well, of course, what are we doing now? We're trying to move forward saying that, you know what? Well, I did a lot of stuff in front of you. Of course, I'm doing stuff where I'm always encouraging you to try, but here's the point where you're starting to try, and that's supplemental activities. It's not enough to watch someone do something. You have to supplement that by trying to figure out what's going on. And I'm saying one of the best ways to do that, at least as a minimalist approach, is by working similar problems. And that's what we do here. We design homework for you. That's similar. Again, I want to tell you other supplemental things you might want to do, which I would recommend you do, is read a book on trigonometry, of course. You know, it doesn't have to be the book that we have in WebAssign. You can get any book you want in trigonometry. There's tons of them out there. Some are cheap books, some are really expensive books. It's really the same content, not rocket science. It's real simple stuff for the most part. Now, granted, when I say that, you can make them really difficult. We tend not to. We tend to just indicate that there are going to be problems that are very similar to what we're doing in class, all right? So what I want to do is I'm going to the whiteboard, and I want to emphasize this is a typical what we're going to do. We first teach the material. We teach them interesting concepts and doing example problems, and then we ask you to reinforce it by doing problems that are in the supplemental problem set. All right, so I'm going to go to a whiteboard now. Now this document's going to disappear, right? So when it disappears, someone can say, where did it go? Well, my goal here is to get you guys to realize that this document should be in front of you at all times during the class, right? At all times during this class. So when I share my white screen with you, someone says, oh, where did it go? It's in your hands. The document's in your hands. It's in my hand too, all right? So let me get this opened up first. And I'm gonna do a white screen, a whiteboard. And someone says, well, where are you now? Well, I'm gonna tell you, we're in section 1 of the notes. I'll write this on the whiteboard for you. Section 1. And we're doing homework. Okay, my goal here is to get you guys to do the homework. Now you may say, I still need help. I need to watch someone. Well, you can watch me as much time as you want, but the bottom line is you have to stop watching me and start doing this material. Now you may want to watch first, then put it down and try it on your own. See if you can do it without having any notes in front of you or without having a computer screen in front of you. So number 1, what does it say? I'll read it to you. It says, the angle theta is 45 degrees. If you want, you can write that down in radian mode. And in radian mode, I'll write that down for you. It's 45 degrees times pi over 180 degrees. And what would that be? That would be pi over 4. All right. You could also write down revolutions if you want and write this down for you. 45 degrees. Whoops, made a mistake there. And it's going to be 1 revolution in every 360 degrees. These are things we've already covered in class before. And what's that going to be? Well, 45 goes into 360 8 times. So it's 1/8 of a revolution. All right. I want to point out 45 degrees has a unit on it. 1/8 has a unit on it. But pi over 4 has no unit on it. It's unitless. All right. Now, I'm not saying that was your question, but you should understand 45 degrees is either being pi over 4 or 1/8 of a revolution. What I want to do is read it. It says over here, you should draw a picture of this. So what I want to do is I want to tell you what the picture is going to look like to me, at least initially. There's going to be an x-axis and a y-axis. There's going to be a circle centered at the origin. And I'm going to do this standard position thing. This is going to be the initial side. And then I rotate the terminal side 45 degrees from that initial side. Now it's a positive number, so it's going to be counterclockwise. I'll put this over here. All right. Let me point this out to you. This is the initial side. This is the terminal side. The angle that I rotated it, and I'll write that down for you, is 45 degrees. All right. Now someone says, what's the size of that circle? I'm going to say it's a circle of radius, whatever you want it to be. And I'm going to say, well, you can make it your phone number if you wanted to. But for simplicity's sakes, I'm going to say this is a circle of radius equal to 1 unit. All right. So what I want to do is I want to kind of draw a reference triangle. And my reference angle is 45 degrees. And this is going to be my reference angle over here. This should be well understood at this point, and we've done this many, many times before. So 1 root 2. Now, I said that's like typical for most students. And what I'm going to do is I'm going to scale it. And the reason I want to scale it, I want the radius to be 1. So I'm going to divide all the sides by root 2. I'm going to do that by using an eraser. I'm going to write that down for you. So if I divide root 2 by root 2, I get 1. If I divide 1 by root 2, I get 1 over root 2. And if I divide this side by root 2, I get 1 over root 2. So I'm going to say that I kind of know that this here relates to that triangle there. So I'm going to write this down. I'm going to say the abscissa, which is x in this case over here, is going to be 1 over root 2. And the y is really the same thing. Okay? All right, I'm going to keep reading it. So I think I've answered R, I've answered X, and I've answered Y. It says use it to evaluate the sine theta, cosine theta, and tangent theta. Push on the side. And I'm going to put sine of theta. Well, theta is 45 degrees, right? The cosine of theta, 45 degrees, and the tangent of theta, which is 45 degrees. Well, you would need to know their definitions. And the sine is going to be the ordinate, which is y, over r. So it's going to be 1 over root 2 divided by 1, which is 1 over root 2. Now, some students are upset by that number because their teachers in Math 1 told them you shouldn't write it that way. So if you want, you can write this as root 2 over 2. Either one's fine. Now, what's a cosine? It's going to be now the abscissa, which is 1 over root 2, divided by the radius, which is 1 over root 2. Again, if you're upset by that, you can put down root 2 over 2. Now, what's a tangent? It's going to be that the ordinate, which is 1 over root 2, divided by the abscissa, which is 1 over root 2. And what's that going to be? The number 1. All right, I'm going to get my little red pen out, and I want to see if I did a good job in answering the questions. Certainly, I'm seeing they're putting down, 45 degrees. I'm seeing the pi over 4. I'm seeing the 1/8 revolution. Whatever you're comfortable with. I see the r is 1. I see the x is 1 over root 2, and I see the y is 1 over root 2. I see the sine of 45 degrees. They say it is 1 over root 2. I see that over there. They say the cosine of 45 degrees is 1 over root 2. And they say the tan of 45 degrees is 1. So I'm feeling pretty good about that. All right. Very similar to what we've done in class, if not identical. All right. What I'm going to do now is go to number 2. Now, for students that find this to go too difficult, too fast because they haven't done any work, you got to go back and do work first. And this should not seem to be going too fast. However, it's a video. You can pause this and play it at your convenience. When I say it's a video, it's posted as a video. Now, you might be watching this thing live, but eventually you start to realize you can watch this off schedule at your convenience. Put number 2 down. And again, I'm going to read it to you. It says, let theta equal 270. I'm going to write down the radian measure. No, you don't have to do that, but it's nice if you can. Now it would be what? I'm going to say 90 degrees goes into both of those numbers. And it would be 3 pi over 2. I'm also going to put the revolutions down. And I'm going to say 1 rev every 360 degrees. 90 goes into that 3, so it's going to be 3. When I say 90 degrees goes into 273 times, and it goes into 364 times. So 3/4 of a revolution. Let me erase this over here. I write the word rev down. Again, I'm not saying they ask me to do that. You should understand there's a relationship between the measuring systems. That 270 degrees, I prefer that number, but I also know it's 3/4 revolution or 3 pi over 2. Now, what do they want me to do? They say first draw the unit circle. I'm going to put that down for you. Set it at the origin. Okay, first draw the picture, unit circle. I'm going to kind of, put my initial side down. I'm going to rotate now 270 degrees. So it's positive number, so it's counterclockwise. 90, 180, 270. All right, I'm going to locate the point here on the circle, and I think I'm ready to do it. All right, now what do you mean by ready to do it? I'm going to write down this is x-axis, this is the y-axis, and I'm going to write down the point now. And what's the x-coordinate? 0. What's the y-coordinate? It's actually, if this is a unit circle, -1. All right, so I'm going to, read it to you again. It says, draw the picture. I've done that. It says determine the x, y, and the r. Let me write that down for you. X is 0, y is -1, and r is 1. This is a unit circle. A unit circle means radius 1. What do they want me to do? Use that information to evaluate the sine, the cosine, the tangent. I'll write that down for you. Sine of 270, 270 degrees. The cosine of 270 degrees and the tangent of 270 degrees. We have an answer key to look at. I want to point out as I'm talking about these guys over here, I'm going to start talking about x's and y's and r's and not abscissa and ordinate. But here's the deal. I want to point out this is an abscissa in this picture. This is an ordinate in this picture. And this is the radius of that unit circle. Now, how's the sine defined? The sine is defined as y, according to these definitions over here, this y over r, which would be -1. Write that down for you. Now, how is the cosine defined? The cosine is defined as x over r. Well, 0 over 1 is 0. And how's the tan defined? And just to make sure you understand what we're talking about over here, the tan is defined as the y over this. Well, that's a trouble. I want to point out -1 divided by 0 is undefined. Now, as you're studying, you're going to realize you're going to make mistakes. But let me get my red pen out and see how we did. I'm seeing the 270 degrees. I'm seeing the 3 pi over 2, and I'm seeing 3/4 revolution. I see the x is 0. I see the y is -1. Again, we're looking at the answer key. R is 1. The sine of 270 is -1. The cosine of 270 is 0. And they claim the tangent of 270 degrees is undefined. Let's go to problem number 3. These should seem like relatively simple problems once you catch on. Now, if you don't catch on, nothing's going to get simple for you. All right, now I'm going to write this one down, and this is number 3. They say theta is 5 pi over 3. I do not see any degree symbol, and I don't see REV or rotation, so this must be a radian measure. What I want to do is convert it to different measures. So I'm going to do 5 pi over 3 times 180 degrees over pi. And let's see, pi's would cancel. 3 goes into 180, 60, and 5 times 60 is 300. So 300 degrees. I'm also going to do revolutions. And there's going to be 1 revolution in every 2 pi. And what do I notice? The pi's cancel off. And what do you get? 5/6 of a rev. Now, again, I'm not saying they ask you to do that, but you should start to realize you can convert back and forth between the various measures, whether in radian, degrees, or revolution, you go back and forth between them. What are most people comfortable with? I guess they're comfortable with the 300 degrees. Now, what they want to do is they want me to find the values of the 6 trigonometric functions. Well, I can't say this enough times. We're going to visualize it, right? And I'm going to put that circle down. Now, whether that circle is a radius of 1 or whatever, it really doesn't matter, but I got to visualize 300 degrees. So I'm going to do, this is my initial side here, and I'm going to rotate. So, 90, 180, 270. All right, I got to go 30 degrees more, right? I'll put that down, something like this over here. And let me emphasize this to you. The reference angle is the angle made with the abscissa. And what's that going to be? It's going to be 60 degrees. All right, this is where a lot of students struggle. I want to kind of draw the picture for you of a triangle that's 60 degrees over here. All right, you should have this down pat, by the way. So, 2, 1, √3. So I'm going to put this point over here. And what I'm doing, I'm actually visualizing a triangle there where the reference is 60. And again, for some students, it's difficult. And again, if it's difficult, we're more than happy to help you with this. I really mean that. We're happy to help you. We want everyone to get through this. All right. So I'm going to put down the x coordinate. This is x, and this is y. And what's the x coordinate going to be? Well, I'm kind of looking at it, and I'm going to say it's 1. Definitely a positive number. I'm seeing that. What's the y coordinate? -√3. And what's the r now? The r is actually 2. All right. So let me write this down for you. X is 1, y is -√3, and r is 2. What I want to do is I want to write down the values of the 6 trigonometric functions. So let's write this down. All right. Now, I don't want to keep writing the number down again, so I'm going to just simply say theta is 5 pi over 3. And again, it's easy for me to write that down. Sine of theta cosine of theta, and tan of theta. I'm going to erase it. It doesn't look like an equal sign, does it? All right, sine of theta is going to be, looking at these letters, by the way, is going to be, let's see, y over r, which is minus root 3 over 2. The cosine of theta is going to be x over r, which is 1/2. The tan of theta is going to be y over x, which is going to be minus root 3. Now, once I have these down here, I can write the reciprocals down. The reciprocal of sine is the cosecant. And what's the reciprocal going to be? Minus 2 over root 3. Now, the reciprocal of cosine is secant of theta. What's that going to be? 2. The reciprocal of tangent is cotangent. And we'll look at the answer key later. What's the cotangent? The reciprocal of the tangent, which can be minus 1 over root 3. All right, this is what they asked for. I'm going to put a box on it. And I'm going to go through grading them. And what do I mean by grading? I'm looking at the answer key. So I'm seeing this. I'm looking in the blue area, the answer key that's provided to you. I'm seeing this. I'm seeing this. I'm seeing cotangent. I'm seeing secant. And I'm seeing cosecant. I'm seeing them all. I feel good about that. Let me go to number 4 now. And again, if you've studied and mastered the material, these questions should seem relatively simple. All right, I'll read number 4 to you. And number 4 says, there's a point minus 1, 2 on the terminal side of an angle in standard position. Well, it's really the same thing. And I'll put this over here for you. I'll put my circle down for you. Again, that'd be a great circle. I mean, my circles never look that good to me. Now, what's the point going to be? They say it's minus 1, 2. All right, so I'm going to look at that. I'm going to say maybe something like this over here. I'll put the point down. Minus 1, 2. All right, so that's the point on the terminal side. So this is the initial side. This is the terminal side. Okay, and this is going to be the angle theta. Now, what do I know about theta? I certainly know it's bigger than 90 degrees, and it's less than 180 degrees. All right, now, I don't think you're going to ask me that question yet. That comes later in the semester. But right now, I want to, kind of write down, this is the x-axis. This is the y-axis. I'm going to write things down over here for you. I'm going to write x is minus 1, y is 2. Now, the r is going to be equal to the square root of x squared plus y squared. And that's pretty easy to do. What's that going to be? Well, the r is going to be 1 plus 4, so the root of 5. Again, minus 1 squared is 1, 2 squared is 4, 4 plus 1 is 5, square root of 5. Okay, I'm going to keep reading it. It says the point, terminal side, angle, center position. I did that. Draw a picture. I did that. Determine x, y, and r. I've done that, and I'm looking at that. Next thing is determine the quadrant that theta's in. Well, theta is in the second quadrant, in quadrant 2. Okay? All right, let's keep reading it. Evaluate all six trigonometric functions. Well, I'm going to do that. Sine. I don't know what theta is, but I'm going to write it down. Cosine of theta. Tangent of theta. I like to do these three first. The sine is going to be y over r, which is 2 over root 5. The cosine is going to be x over r, which is minus 1 over root 5. And the tangent of theta is going to be y over x, so it's going to be minus 2. All right, let's put the other ones down, the reciprocals. Cosecant of theta, secant of theta, and the cotangent of theta. Root 5 over 2. I'm just doing reciprocals. Whoops, I got a little jumpy there. Root 5 over 2 minus root 5. And this one's going to be minus 1/2. All right, let's get my little red pen out and see how we did. All right, I got the x right. I got the y right. I got the r right. Theta's in quadrant 2. I got that one right. Sine is this one. Looks pretty good. Cosine looks pretty good. Tangent looks pretty good. Again, I'm just looking at the answer key. That's all I'm doing. I'm not thinking anymore. I'm just looking. I'm grading as if I were a robot. It says the cosecant is root 5 over 2. It says the secant is minus root 5. And it says the cotangent is minus 1/2. I feel good about that. I'm going to move on to 5 now. Again, these should be relatively simple questions if you've studied the material, attended lectures, paid attention, and made some effort to understand what's being presented to you. So it's one little odd. They're not using theta for the angle now. They're saying T is 135 degrees. You're going to see they're going to use a variety of letters, all right? But anyway, whatever letter they use is fine by me. So I'm going to convert it to the radian. That's going to be, let's see, pi over 180 degrees. I notice those numbers are divisible by 45, so it's going to be 3/4 of a pi. I'm also going to do revolutions. And I'm going to multiply this by 1 rev. And let's see, that's 360 degrees, right? And that's going to give me, well, again, divisible by 45, that's going to give me 3. And that goes in, let's see, 2, 4, 6, 8 times 3/8 of a rev. I realize when someone says they didn't ask me to do that. I'm not saying they did. I'm just saying you have to be able to convert back and forth between the systems. All right, so let's take a look at this. It says, first draw a picture. I'll do that for you. And typically my pictures don't look great, but they're good enough for me to, kind of understand where things are. That's my circle set at the origin. Whether it's a unit circle or not is incidental to me. It doesn't much matter to me, but I need to draw this initial side in, this initial side. And now I got to rotate, going to be 135 degrees. So what's that going to be? Well, I got to go 90, and then I have to go 45 degrees more. All right, that's going to be the angle T. All right, now of course there's a point over here, and the question is, what is it? It's a reference triangle. And what's that reference triangle going to be? I'll put this on the side. It's a 45, 45, 90. 1, 1, root 2. And yes, you should know that triangle by now. So I'm going to look at the picture. I'll put the x-coordinate down, clearly negative. It's going to be -1, looking at my reference triangle. The y-coordinate, clearly positive. And the r, of course, the radius of a circle, is a positive number. Let me write this down. X is -1, y is 1, and r is the root of 2. All right, I'm looking at my reference triangle to get that. So again, I'm reading through it, and now it says find the cosecant, secant, and the cotangent. I'm going to write that down for you. Move this over here, and I'm going to do certainly the sine too, even though they didn't ask for it. I'm going to do the cosine. I know they didn't ask for it, but I like to do it anyway. I'm going to do the tangent. And I'm going to write these down pretty quickly. The sine is going to be, according to my definitions, 1 over root 2. Cosine is going to be -1 over root 2. And the tangent is going to be, let's see, 1 over -1, which is -1. They didn't ask for that, though. They asked for their reciprocals. So let's write them down. That's reciprocal with sine, so it's going to be root 2. That's the reciprocal of cosine, so it's going to be minus root 2. We'll check it in the calculator. And let's see, cotangent is going to be reciprocal of tangent, which is going to be -1. And I'm going to go to my answer key, and I want to see how I did. I'm going to move this around a little tiny bit. And I see the 135. I see the 3 pi over 4. I see the 3/8 of a revolution. I see the x's, let's take a look, -1. I see the y is 1. Wow, looks pretty good. I see the r is root 2. All right, let's see how we did in the other stuff. All right, cosecant of theta, root 2. Secant of theta, I'm just looking at the key, by the way, like a machine. Looks good. Cotangent of theta, -1. Did a great job. Let's keep going. And again, these should be relatively simple questions. Let's go to number 6. And what does number 6 say? The terminal side of theta lies on the given line in the specific quadrant. Find the values of the 6 trigonometric. Oh, this looks like it's something new to me. So what does it give me? Y equals -3/2 x, and it says it's in this quadrant over here. All right. So what I want to do, it's in that quadrant. I'm still going to draw a circle, but I'll do that later. I want to get an x that's in that quadrant. I hope you realize what quadrant we're talking about. This one over here. The x would have to be a positive number. Now, someone says, what number are you going to pick? You can pick any positive number you want, but I'm going to pick an easy one. I'm actually going to pick the number 2 for x. And someone says, why do you pick 2? It's easy for me to do that. What would the y be? -3. So I put that down for you. I'm going to put the point down for you. That's 2 over and then 3 down. Okay. And I'm going to draw a circle now. And sometimes your circles never look good. They really never look good. I know that. All right. Put my initial side down here. And start to rotate. I'm going to rotate to this thing over here. That's theta. Okay. It says theta lies in a terminal side. Well, there you go. All right. Let me put my point down for you. That's going to be 2 comma minus 3. So I know x is 2. I know y is minus 3. And what's r going to be? And again, I want to remind you, r is the square root of x squared plus y squared. What do you get? 4 plus 9. That's 13. So it's the square root of 13. What do I do? Find the values of the 6 trigonometric functions of theta. I'm going to put that down now. All right. Let's put this over here. Relatively simple to do. Sine of theta, cosine of theta, tangent of theta. What's sine of theta? Well, it's going to be the y, which is minus 3 over root 13. That's the r. Cosine is going to be x, which is 2 over root 13. And the tangent is going to be y over x, which is minus 3 over 2. Let me put down the other 3. It's going to be cosecant of theta. That's a reciprocal of sine, which is going to be minus root 13 over 3. The secant, which is the reciprocal of cosine, which is going to be root 13 over 2. We'll get an answer key and we'll look at it later. And the cotangent is going to be reciprocal of tangent, which is going to be minus 2/3. I'm going to get my red pen out and I want to see if I've got it. I want to see if I got the right answer. I make mistakes and everyone does, but you want to fess up to those and correct them if you can. I see this. 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 I'm actually looking, by the way, and I see this. I'm checking it. All right. Let's keep going. That looks pretty simple. And again, for the students finding it's difficult to follow, go back and study the notes before you try this. You go to number 7 now. I'll read it to you. It says, find the point x, y in the unit circle. I notice a unit circle now. What does that mean? It's a circle of radius 1. This is a unit circle, r equals 1. It says find the point on the unit circle that corresponds to the real number t equals minus pi. I want to point out, I'm going to write this down a little differently. I'm going to convert it 180 degrees over pi, which would be minus 180 degrees. I could also do, rotation. So minus pi, that's 1 revolution or rotation over 2 pi. So it's actually minus a half of a revolution or rotation. So I'm going to visualize that initial side. And what I have to do, I have to rotate this thing 180 degrees clockwise. Let me do that for you. So going in this direction now. And what are you going to get? It's going to be over here somewhere. All right. Let's put a point down. It's over here. What's the point going to be? Well, I'm kind of looking at it. It's a unit circle. So it's going to be minus 1 for the x, nothing for the y. All right. I'm going to keep reading it to you. It says find the point x, y. I've done that. It's right there on a unit circle. And it says evaluate sine of theta, evaluate the cosine of theta, and evaluate the tangent of theta. All right. The sine of theta, again, you should be getting better at this. It's going to be y, which is 0 over r. That's going to be 0. The cosine of theta is going to be the x, which is minus 1, over the r, which is minus 1. The tangent of theta is going to be the y, which is 0 over minus 1, which is 0. Okay, I'm going to get my little red pen out. I'm going to look at it and see if I got everything done right. All right, so the question is, did I get the x, y, and r? The x is minus 1, the y is 0, and the r is 1. Did I get sine? Oh, you know what? I said theta. It's not theta. Let me get my eraser out. I just noticed that. This is not correct. I got to erase that. It's t. I do that sometimes. I'm so used to saying theta. Okay, let's take a look. And did I get this? Yep. Did I get this? Yep. Did I get this? Yes. Things are looking good. Let's go to number 8. It says use the value of the trigonometric function to evaluate the indicated functions. Well, let me write this down now. This looks like it's a tough one. Sine of t is minus 4 over 9. And then it says t is bigger than pi and it's less than 3 pi over 2. Well, I'm getting a little better at this. Pi is 180 degrees and 3 pi over 2 is going to be 270 degrees. If you want to use revolutions, this is 1/2 of a rev or rotation. And this would be what? 3/4 of a revolution or rotation. So this is why you go through all that business. We got to get familiar with how to get these things done. And that's knowing the measures. So what do I know about this thing? It's going to be a circle. Never good, is it? And what do I know about this thing? And it might be tough, but I know this circle has a radius. So I like the radius to be 1. It's not 1. The radius of this circle here, whoops, I'm sorry about that. The radius of this circle over here is 9. Right, how do I know that? Well, this is defined, right? How's it defined? Now it's going to be defined by this number here, which is actually the ordinate over the radius. All right, let's see if I can do that. And I'm going to try to, I'm going to ballpark it, but I want to get done right, okay? So I'm going to say, maybe over here somewhere. Let me put this down. Initial side. And I want to put the terminal side down. I'll tell you why I'm putting it there, by the way. The angle, this is the angle, T. All right, now what do I know about the point? All right, I know the x-coordinate. I'm sorry, I was thinking cosine. I got to erase my picture. And I'm sorry, I was thinking cosine, but I did a wrong picture here. Got to get my big eraser out and start erasing things. So once is that important? It's important. All right, so remember, minus 4 is the ordinate. And I'll put that down for you. All right, let's go over here. Initial, terminal. All right, and we want to put the point down. So what's the point going to be? Well, it might be tough to do, right? The only thing I really know is the y-coordinate, the ordinate, minus 4. I want to point out, why'd you put it there? I know it's between the 180 and 270. Now, why here and why not down over here? Well, this is minus 9 down, so it's approximately minus 4 down. All right, that's about minus 5, that's minus 9. You get the idea? Not halfway there, but almost halfway there. So I got to figure this guy over here. All right, now before I do it, I want to tell you that's the x-coordinate. I hope you know by looking at the picture that it's got to be a negative number. All right, now let's write this down. So it's going to be r squared equals, not r squared, I'm sorry. Yeah, I can do that. X squared plus y squared. Now what's r squared? 81. I don't know x. What's y squared? 16. All right, now I got to do 16 from 81. That's going to be, what's that going to be? I guess 65, right? Equals x squared. Now going back to math 100, x would equal plus or minus the square root of 65. It can't be both, by the way. There's a point there. And looking at it, I hope you realize it's got to be minus root 65. All right, let's write this down. X equals minus root 65 y equals minus 4, and r equals 9. Again, we did not beyond making mistakes. Now, someone says, well, what's their question now? Why do all that work when you don't know what their questions are? I need to understand this. All right, so my understanding is I know x, y, and r. What's their question? Well, let's write this down. What's A? It's tangent of t. What's the tan of t? The tan of t is going to be, let's see, it's going to be y over x, it's this over here, which can be 4 over root 65. We'll check it later, okay? Let's put b down. What's b going to be? Cosine of t. And what's cosine of t? Let's take a look. It's going to be minus root 65. That's the x over the r, which is 9. All right, let's get my little red pen out and see how we did. And I'm looking at letter A. Got that right. Let's look at letter B. I got that one right. That's good news. All right, let's go to number 9. Don't be discouraged. You can always rewatch these guys as many times as you like to learn the material. My gut feeling, though, is that if you're having trouble with this, you have not studied what we presented to you. You must study what we present before you move forward. So this one over here, this is number 9, and it says secant of theta is minus 2. And they say there's 2 solutions to this problem over here that they want you to find. I got to be honest with you. There's an infinite number of solutions, but let's not worry about that. What I'm worried about is that secant's a little bit foreign to me. So what I'm going to do is write down something more familiar to me, the cosine of theta. And what would that be? Well, it would be the reciprocal of that, which would be minus 1 over 2. So what I want to do is go back to what I've always done, which is draw the circle down. Now, again, if someone says, what size of the circle over there? R is 2. All right. Now, how do I know that the bottom number is R is 2? Now, I'm looking at the minus 1. I'm wondering, that's the x value, isn't it? So that's going to be over here somewhere. All right. So the question is, there's 2 different places this occurred. It's the initial side. It may have hit it here. That's one possibility. Because the x coordinate over there, I'll write this down for you, minus 1. You know, I think I can put the y down now too. And let's see if I can do that. And I guess you have to use Pythagorean Theorem, right? So, r squared is equal to x squared plus y squared. And r squared is 4. X squared is 1. So y squared would have to be equal to 3, right? I hope you look at the picture and you know y is positive there. That would be root 3. All right, let's do another one. And I'm going to put over here now. So this could be 1 theta. Whoops, over here. And this could be 1 theta. We'll figure it out later, by the way. Again, I'm looking at really the same story almost. And it points in a different location, by the way. So it's still minus 1 for the x. And the y would now be minus root 3. All right, I'm kind of looking at it, and I'm wondering, it's a triangle that I'm familiar with. All right, so I'll put the triangle down for you. It's a reference triangle. And I'm seeing it. And again, for students that have trouble with this, please come by and see me during office hours, and we can go through triangles as many times as you like. 60 degrees. So the reference angle is 60 degrees. All right, what does that mean? That means the angle that's formed with the x-axis is 60 degrees. So let's talk about the first angle. The first angle is between 90 and 180, but the reference is 60. So if you 180 and backed off 60, you'd be at 120 degrees. I'll write that down for you. Let's do the next one. The next one can be, 180. I'm going to the green one now, and the reference is 60. So 80 plus 60 is 240 degrees. I'll write that down for you. All right. So let me just read it again to you, make sure you understand what it said. It said find 2 solutions to the equation. We did that. We found 2 solutions. One of the solutions should be between 0 and 360, and the other one should be between 0 and 360. They're both between 0 and 360. They also say I should put down the radian measure. All right, let's write that down for you. Before I do that, I want to point out that this is 2 times 60 degrees. And this is going to be what? 4 times 60 degrees. So it would sure be nice to know what 60 degrees in terms of radian. So what's that going to be in terms of radian? Well, I'm going to multiply it by pi over 180 degrees, which will be pi over 3. So what's this going to be? Well, 2 times 60 would be 2 pi over 3. And 4 times pi over 3 is 4 times pi over 3. Put a box in this. Get my red pen out. See how I did. They said 120, 240, 2 pi over 3, and 4 pi over 3. Feeling real good about that. All right, let's go to number 10. Number 10 is the last problem. And what does it say? It says, for what values of theta? Oh boy, this looks like another tough one for me, right? F of theta is equal to the cotangent of theta. Well, again, I like that X, Y, and R business. And the question is, how's this defined? It's defined as R, not R, I'm sorry. I'm thinking. All right, let me should write this down. Tangent of theta is Y over X. So the cotangent is going to be X over Y. Let me get this out and erase it. So when would this be undefined? Well, let's look at it. I'm going to be careful about it. It's when the Y is 0. Question is, when are the angles? What angles make Y to be 0? Well, I'm going to start writing them down for you. At 0 degrees, at 180 degrees, and you may wonder what it is. If you rotate it around, let me draw a picture for you. This would be 0 degrees, so that's clearly a 0 degrees, Y is 0. If you went over here, you get the idea? It's still going to be 0. And it goes round and around and around. Next one will be 360. And they actually just go up by 180. So all I was going to say is that it's going to be the multiples of 180 degrees. So I'm going to say 180 degrees, K, where K is an integer. All right. You could also write down pi K, the multiples of pi. Same thing. Let's read the solution. It says integral multiples of pi. And again, integral multiples in case an integer. You should look back over the definitions to see why that's the case. What's the definition? It's really going to be the x, which is the abscissa, and y is the ordinate. When is it undefined? When the ordinate is going to be 0. That only occurs when it's along the x-axis somewhere. Okay, this is it. We're done. And I want to just simply briefly go. And I know this is difficult. This is the beginning part of using a computer algebra system. All right, so what I want to do is I want to just briefly go to another share. And just give me 1 second to do that. And I'm going to just launch Sage. Give me 1 second. And don't worry about what I'm doing at this point. Okay. I just went to a website here. Give me 1 second. www.sagemath.org. You should go to that website. All right. I know it's difficult. You want to start thinking about moving beyond your safe space and starting to think about using technology. All right. So like I said, I went to that website. You could download the software if you want. But I think for right now, it's going to be overwhelming to a lot of students to download stuff. So I want to go to this thing over here, which allows me to use Sage on a network of computers. Again, you have to register an account for this. I already have an account over here. You go through that. You want to use your real name, just use whatever you want to use. I'm going to, it says 4 days ago. Yeah, I guess I was there about 4 days ago. So I don't use this too often, by the way. But I don't know. Let me open it up. Let me cancel this. Let me see what we're open. Yeah, I'll start the project. I got some files over here, but if you wanted to, you could start a new one. Let me just click that for you. Now, what I want to do is I want to create a Sage worksheet. And I'll do that. And a lot of people get this. I don't know what I get to do with this, but you can type in something really easy like 1 + 1. Now, what would most students do now? They hit the return button. Nothing's going to happen. I'm going to go back up, and I want to emphasize to you, you must hit the shift return key. So shift return. And when I do that, what's going to happen is going to launch an instance of a Sage server that's going to ask another computer to actually compute the result. I just did that. I'm going to type in clear. Remember, shift return. Oh, you know what? I'm sorry, clear is not defined in this computer. That's on my terminal. Let me just type reset though. All right, shift return. The problem I have with this over here is that someone says, what do you want to do with this? I want to type this information in over here. Let me do that. Theta equals var. Someone says, what's this? I'm defining theta now as a variable. Remember, shift return. You get the idea? Then I'm going to set theta equal to pi divide by 3. Remember, shift return. So if I type theta now, what's going to return? Shift return, pi over 3. That's 1/3 of a pi, by the way. Sine, Theta, shift, I'm hitting the shift button, return. So forth and so on. Yes, you should do it a hand. Here's the deal though. We're trying to introduce to you a computer algebra system. All right. I'm going to go to a different computer algebra system. Not a different one. I'm sorry. I didn't mean to say that. I'm going to do a different incident. I'm going to do Sage. I'm going to type in the word clear. It clears. I'm not doing shift return. It's my terminal. This is running on my computer. Reset. Right. We just did this before, right? This is running on my computer, no one else's computer. Var. You get the idea. I'm just typing the same stuff in over and over again. Theta, pi over 3. And then I can type in like sine, theta. You get the idea? I'm just typing, so forth and so on. And you can do that as long as you like. Get used to this though. Get used to using software. All right. And most stuff we do it by hand. You notice when I was doing my problem set, everything was done by hand. You want to start to learn how to use a computer though. All right.